Hello YouTube, welcome back to my channel. I'm SweetTips. Today what I have is 5 pieces of gold-filled jewelry here that I want to work with. Say one day you come across something like this and you say, you know what, I'm going to try to give this thing a shot. You got to be able to understand and know how to identify the gold-filled scrap, because you don't want to put gold-plated material in here. You'll just end up making a big mess and get no gold. If you look right here on this piece, it says 1/20th 12K gold filled right on it. Another thing I'd like to notice about this piece here is around the edges up here, the gold filled material has worn away. It's worn off. So that's going to reduce our yield when we go to process this. This piece has been worn by someone, and the gold-filled material has worn away and exposed the brass base metal. On this next piece, right here on this little band, you've got some initials right here that just says GF. GF, right there. Okay, on this next piece, if you look right here, there's a area that has a well-defined border where the gold-filled material has worn away and exposed the brass. This one does have a marking here, but it's very difficult to read because it's been worn away. It's right down here. If I get the camera to focus. Right there. Alright, this one has a marking right there that says 1/20th 14K GF. And last but not least, this is a chain. Right there it says 14/20 GF. So I've selected these 5 pieces. And now what we're going to do is get a weight on them and then go out, get this stuff in some acid and dissolve all the metals, base metals out, so we can recover the pure gold foils from this gold-filled jewelry. Got 136.0 grams. I've got the gold-filled material out here in a melt dish. I'm going to burn all the people off of it, the oils and greases. But first, what we're going to do is, I've got some solution here from my previous video where I've refined some gold-filled watches. The solution is still going to have active nitric that can dissolve the base metals out of this gold-filled scrap. So normally I would put distilled water and fresh concentrated nitric in here, but I'm going to reuse this solution to start with to use up all the nitric acid that's in this solution. Now I'll use my torch to heat this material to redness and burn off all the oils and greases and any other combustible material that might be clinging to it. Just heating it to redness here. I don't want to melt it. If I melt it, then it's going to have a tendency for the gold coating to try to alloy with the brass base metal, and I I don't want that to happen. So I'm just going to heat this to redness, burn off all the oils and grease and any other combustible material. That should do it. And now what we're going to do is just pick this up and add it to the beaker that has our nitric solution in it. Carefully. And now I'm going to turn some heat on here, and we're going to start dissolving out the base metals. Here you can see by the reaction that this solution still had plenty of active nitric acid in it. The solution has been on boiling now for about a half an hour, and I'm looking down in there and I'm seeing something that doesn't look quite right with this piece right here. That's not looking like gold-filled material here. I just trusted the marking. I guess I could be wrong, but it looks like something other than gold-filled material. What I'm going to do is take it out, put it in a beaker here, and look at it a little bit closer. See if we can determine if this is gold-filled or not. Alright, the rest of the stuff in there should still be good to go here. I'm going to add a little bit of distilled water and some more nitric acid. I think all the nitric that was available in this solution has been consumed, so I'm going to add a little bit more concentrated nitric acid here slowly. That was probably 50 to 70 milliliters there. Put the lid back on and let this cook. Now let's take a look at this thing down here and see what we got. I trusted the marking, but it's just not looking right. When I looked at this piece, just didn't quite look right in the jar there in the beaker. So what I'm going to do, add it back in and just hope for the best here, which is probably not a very good technique for a refiner, but it does have a gold appearance to it now that I look at it a little closer. It just kind of looked weird, like it was steel. I'm going to add it back into our batch here along with the distilled water. The time is 2:10 p.m. I had this on boiling for a couple hours now. I'm fairly confident all of the nitric has been consumed out of this now. Take it down off the heat. I'm going to add about half a liter of distilled water. I'm going to let this cool down now. And then I'm going to get that solution off of those pieces of gold-filled material. Allowed this solution to cool down now. I'm going to pour it through this filter and get the solution off of the gold-filled material now. Alright, here's a look at the material we've got here in the beaker. It's coming apart just like we want it to from the acids. What we're going to do now is put this back on the heat over here, add some fresh distilled water and fresh acids. Okay, we're going to put the heat back on here, turn it up to about medium. I'm going to add about another 200 milliliters distilled water. Then we're going to add some more concentrated nitric acid here. Continue to dissolve the base metals out of this gold-filled scrap. It's about 100 milliliters of concentrated nitric. We'll just let this go now. We're about 15 minutes shy of 5 hours. As you can see, there's plenty of fumes still being generated in this. I'm going to stick the rod down in here and we're going to take a look and see what we got here. Oh yeah, those are foils, gold-filled foils, starting to float on top of the liquid there. And this is what we're wanting to see here. It's going to take about a half a liter of nitric acid to get all the base metals out of this. Alrighty, this funnel here, this filter, doesn't really have any kind of valuable material in it. Just going to stick it over here out of the way. What we're going to do now is make some room in this flask. This is the first extraction, and it's going to contain some silver, so I'm going to save this solution and get the silver out of it later on. Alright, just to show you that we've got some silver in this solution, get a little bit of it in this beaker here, and then we're gonna got some hydrochloric acid over here in a dropper bottle. I'm going to add some hydrochloric acid to the solution and we'll get a cloud of silver chloride precipitate out if there's silver in it. Just a very slight tint of cloudiness there, not very much silver at all. Alright, what we're going to do now is, I'm still getting fumes in there. I'm going to add a little bit of distilled water here to keep the thing hydrated. And then I'm going to add a little bit more concentrated nitric acid just to keep the reaction going. Probably another 50 or 75 milliliters of concentrated nitric. We'll just let this continue to cook. The time is exactly 6:40. I've been working on this now for 6.5 hours. You'll notice that there's no more fumes being produced in here. I'm going to take this down off the heat now. I'm going to add about a half a liter of distilled water. I'm going to let this settle and get the solution off of our foils. This has been allowed to settle overnight and the solution's cooled down. What I'm going to do is set up a filter flask here. We're going to go ahead and filter the solution now. There's our gold foils. It's got some purple mud associated with it. That's the color of gold. So we're going to get all this into the filter paper now. I think we've got all the base metals dissolved out. Here's our gold filled material in the filter. I think I see a piece of a hinge here from one of the bangle bracelets. Looks like it might be steel. So I'm going to try to get that out of there. Little piece of steel there. There's another one. Those are the hinges in those bangle bracelets are sometimes made of steel. We don't want that in our group of gold-filled scrap, so I'm going to get that out of there. Now we're going to rinse this out real good. This is our gold foils. They've been rinsed off real good. Now what I'm going to do, get this thing out of the way, and rather than going straight to Aqua Regia here, I think what I'm going to do is put just a little bit more nitric acid on this and boil it in some dilute nitric here, just to make sure that I've got all of the base metals dissolved out of here before I go to the Aqua Regia. I'll put our foils down in the beaker there. I'm going to add some distilled water. That's probably what, about 100 milliliters. I'm going to set it up on the heat here. And then I've got about 30 or 40 milliliters here, maybe a little bit more, of concentrated nitric. I'm going to add that in. And we're going to boil this one more time, just to make sure that all the base metals have been removed. The more time we spend here at the nitric acid, the fewer problems we'll have later on when we go to Aqua Regia. We've been boiling now in the hot dilute nitric for about 5 minutes, and as you can see, there's still some fumes being produced, which tells me there's just a little bit more base metals left in the gold-filled scrap. I'm going to let this boil until all the fumes are gone. Okay, I've started this about 5 p.m. I've added some more nitric and more distilled water. And this is as good as it's going to get. It's 8 p.m. right now. This stuff has been boiling for about 3 hours. So I'm going to declare it done here. I never did get the fumes to completely go away. But I think the base metals are dissolved out of there. It's been on there 3 hours. I'm going to let it cool off now. The last 3-hour nitric boil, cleaned it up real nice here. I'm going to set up a vacuum flask, get that solution off of there, and then we're going to go to Aqua Regia. Here's the nitric acid solution that I just pulled off of our gold foils. I'll save this. It can still dissolve metal. Now what I'm going to do is I've got some hydrochloric acid here. I'm going to add hydrochloric acid to this right now. Here I'm making a critical error. The hydrochloric acid should not be added at this point. That gold-filled material should be filtered out and incinerated first before we go to the aqua regia. I only refine gold-filled scrap 2, maybe 3 times per year, and doing anything that infrequently, we're bound to lose some proficiency. I'm going to set this up on the heat. See if we can get everything to go in the solution here. As usual, I'm going to add a little bit of sulfuric acid here, about a half a milliliter or so, just to precipitate out any lead. Well, I just realized that I've made a critical error here. Just concentrated nitric acid. I'm going to go ahead and put this in now since we've got it in there. But before I try to dissolve this, I was supposed to filter it out and put it in a melt dish and incinerate those foils. So I know I made the mistake. I'm going to see how this turns out now. Okay, it's getting late. I skipped a step. I should have filtered the foils out of that nitric solution, put it in a melt dish, and incinerated it before I put it in this aqua regia. I have problems with stuff tagging along through the refining process that contaminates the gold when I skip the incineration process. So, all right, we got this solution boiling in aqua regia now. Just wanted to show you underneath here. I think we've got everything to go into solution. So I'm going to pull it down off the heat, let it cool off. All right, now I'm going to pour the solution to a smaller beaker here so that we can allow any sediment in here to settle out. And check and see if we got all the solids to go into solution, and it looks like we did. Do a Stannis test here, make sure we got gold in solution. And there you see, gold in solution. It's the following day. I've let this gold settle overnight. All the solids have settled down to the bottom of that container there. So now what I'm going to do is I'm going to draw the solution out of this beaker with a pipette. I'm going to put it through this funnel right here. It's got a filter paper with a 102 filter in it. I want to get this cleared, clarified liquid off of here and into the filter. Let it pass through the filter first. It'll pass through quickly and cleanly. And then when I get down to the bottom, down there where the sediment is, I'll pour that in separately and try to filter that material out of the solution. We don't want to pour that in there all at once because the sediment would clog the filter up and slow this way down. Alright, for the rest of the sediment here, I'm going to reconfigure. What I'll do is transfer the funnel onto this smaller flask up here. And we'll pour this solution that has a bunch of sediment in it into a separate flask because this solution down here is nice and clear. It's already been filtered. I'm going to set this off to the side. And now I'm going to fire up the vacuum and we'll pour this through this filter. Alright, just to review with you. I pulled this clear solution through that filter. It came through very quickly. Now I've taken just the sediment that was in the bottom of the beaker with a solution, a little bit of solution with it. I've poured that into the filter and it slowed way down. I didn't want to have to pull all of this solution through that filter once it gets plugged up with sediment. Down here you'll notice I dropped a little bit of gold bearing solution here. I just sop it up with a piece of paper towel, put it in the beaker and save it. And then next time I dissolve, I'll add that in. The solution is cloudy. So what I'm going to do is I'm going to put a new filter flask up here. I'm going to transfer the funnel off of here into here. And I'm going to pour this solution. See how cloudy it is? I'm going to pour this solution back through this same filter paper. Now that it's loaded up, should be able to trap most of this and clear this solution up for me. This has been filtering now for about 15 minutes. It's coming out just drips at a time on full vacuum. Can't imagine having to pull this whole jug through that filter. We'd be here a while if I had to do that. Alright, we got all that liquid pulled through the filter there. It took about an hour to do all that. And now what we're going to do is we're going to add our solution. Still got a touch of cloudiness, but that's okay. Got most of it out of there. We're going to add our solution to this tall beaker here. And then we're going to precipitate out our pure gold. We'll put both containers into this beaker. Alright, here we go. Sodium metabisulfite going into the solution now. I never get tired of seeing this. Should do it. Now I'm going to get the gold into a filter here. Get it into a melt dish and get a yield on it. Alright, here we are. We're getting down to the bottom of the beaker. We can kind of see the gold powder that's remaining. I'm going to get this into this filter here. And there are three things that are oh so important to refining. They are incineration, incineration, and incineration. To quote one of my mentors on the gold refining forum, Harold V., and I quote, "I don't give a damn what anyone says. Incinerating your material when refining will improve your yields and eliminate many problems." This gold is going to be 99 to 98% pure here. If I wanted to go for high purity, Since I forgot to incinerate the foils earlier in this process, what I would do is I'd melt this gold into a button and then quart it and start all over. That's how important incinerating is to refining these metals. Simply redissolving this a second time and precipitating it again. In this case, since I forgot to incinerate the foils before I dissolve them, I don't think it would work. There would be some junk that follows the gold as you precipitate it. The only way to get rid of it is incineration. I've got some hydrochloric acid here. I've rinsed the gold down into a central mass down in the funnel filter there. I'm going to add this hydrochloric acid, and this will tend to rinse out some of the dissolved metals that might be in there. If you notice, the solution down here has a green tint to it. That could be nickel, could be iron, or it could be palladium. What I'll do is I'll add this green solution to my stock pot. Use some distilled water here and rinse the hydrochloric acid out of there now. Here's our gold mud in the filter. What I'm going to do now is get it out of the filter and over here into this melt dish. Squish down in there real good. Then what we'll do is transfer it over here onto the melt table as usual. And I've got some borax in this container here. I'll coat this thing with a lot of borax to keep the paper from flying out of the melt dish during the melt. And we're going to fire this up with some MAPP gas right now. Here's our button that we just melted right here. You can see it's got a very dirty appearance to it. It's got a little bit of borax flux clinging to it. I could get rid of that with a little dilute sulfuric acid. But I want to show you, compare it to this other button that I got from my gold-filled watches. And this looks way more like gold than this one. During the process of refining this button here, I actually took the foils before I dissolved them, and I incinerated the foils before I went into the aqua regia. This is the one that we just did today. I did not incinerate them, and this shows you how important that incineration process is. You can see a striking difference between the surface of these two pieces of gold. Alright, let's get a weight on this little bead here. We got 2.7 grams. 2.7 grams of probably 97% pure gold here from our 5 pieces of gold-filled jewelry. Well, I hope I impressed upon you the importance of incinerating this material while we're refining. I've got the button that I had from the previous video where I refined some gold-filled watches, and it's got a nice gold color to it. The button that I got from this batch has a very dull color to it. I got 2.7 grams of pure gold. It's probably going to be 97% pure. Divide that by 136 grams of the material we started with, and we get an effective yield of 0.0198 or 1.9, say 2% from those 5 pieces of gold-filled jewelry that we started out with. Okay, I've got one more batch of gold-filled scrap that I'm going to refine here. I may or may not make a video, I don't know yet. I need this gold for my next experiment coming up. I'm going to be making a Woolwell cell, which is an electrolytic gold refining cell, and I need 90 grams per liter of pure gold dissolved in solution for the electrolyte. That's just for the electrolyte. And so I'm trying to accumulate some pure gold so that I can do that experiment. That'll be coming up very soon. This will conclude the video. Thanks for watching.